Hi, uh, hi all. So today we'll be discussing about ESP32 based VGA controller or VGA signal generator, where we have designed that in a constrained resource chip, that is ESP32 S3. So basically, let us understand in a plain term. So that means like drawing a monitor from a tiny microcontroller sounds simple. Connect some sort of wires and display an image, and it looks very simple, right? But basically on an ESP32 with a constrained environment like RAM, ROM, any sort of CPU cycles and the clock frequency, it's very tough on ESP32. That is a microcontroller. So a VGA monitor expects three things basically: a stable rhythm, that is a pixel clock where it periodically refreshes, and horizontal timing marker, so each line starts and ends at exact fixed point, and also a vertical timing marker where it aligns the signals in a vertical position. Like for example, if it is 640 into 480 resolution thing, so it has to give the data or generate the data in such a way that exactly aligns the display ratio. So when I built this to solve a few challenges, like basically the challenges are CPU time, and then the overall memory management is a key because it has very limited SRAM, that is static RAM or instruction cycle RAM. So it is very tough on ESP32. Utilizing every nook and corner on ESP32 makes this project a very special and then a very innovative and novel project. If there is a mismatch or delay of 1 millisecond or any sort of timing in this clock cycle or head sync or v-sync signals, then the overall display that we see on the screen will be shifted, or it will be vertically inverted, or we can see this kind of errors. So that important is the timing in the circuitry. So that is why we have used a binary ladder, resistive ladder, where at that point of time we'll try to convert digital signals into analog signals, and then try to control these things with mathematical calculations. For example, let us think about a monitor which is of 2003 or 2004 manufactured, and we don't have HDMI support in the monitors, and we may have to use that monitor for the futuristic purposes, or right now for simple purposes. We need not invest so much of money in high-end GPUs or CPUs. So instead we can directly employ our a hardware model or hardware circuitry, which can solve the problem in just $300. So that's the overall intention of this project to generate. So now, when coming to technical summary, like we have the platform, what we have targeted is ESP32 S3. We have opted that because it has a built-in Wi-Fi, so it can build a robust pipeline between your IO, that is image uploading, and controlling. So basically, there will be a server hosted on the ESP32 S3 with efficient memory management techniques. So like that, we'll be uploading the content with a graphical user interface, HTML plus CSS based window. So even that, we have a standard payload system or payload standard what we have made particularly for that to deal with. So fine, let me give you a demo right now. So this is the display or VGA monitor or a TV, which is based out of 640 into 480 standard resolution. So now this is the data cable. So I'll just plug in here or power it up. You can see the model. So now I have just turned it on, so I'll get a developer flash. That means these are my details, what I have given it as a developer flash. So after a few seconds or a few delay time, it starts loading. So right now by default there is a staff list which is running here. So let me try to you can see here, this is the overall GA what I have provided here. So you have a green light here that is connected to 192.168.1.150 by default, which is set in the Arduino code here what I have programmed. So the thing is, now let us try to remove this block or this block of overall table, and let us try to see. So for example, let me remove this. I have removed the table, and then I'll just zoom the logo into a big thing. and then display here. So if I can customize this here, maybe you can see correctly here, I'll try to delete some sort of slots which are given here, those scrolling slots, and then try to upload it. So once if I click on upload here, that should automatically dump into the IP here. So you can see here, this issue is due to RAM. So basically the lack of RAM inside to process the reception of data pipeline, and also to show the screen, or to refresh the data on the screen per second or per frame per second, it's a bit tough. So due to lack of RAM, this seems so, I mean, like blurry. That is not a fancy graphic what I have given for to show the upload status, but still it's a disadvantage. Maybe that may look little fancy, but still it's a disadvantage due to lack of RAM. So now you can see here there is a developer flash, and then now here you can see. So this is the GUI. Please come here. So here we have these many options. So the first thing is we have a screen. Let me show you. So for example, I'll remove this main. I can just close this header also. So we'll get a blank space of data or blank area playground where we can play different sort of I mean, like screen settings. So just now, I mean, like, let me choose an header here. So for example, if I go to GUI and then IoT, I will get image. Just a second. Yeah, so this one, just tick it. So it's 120 the header size, and then I have kept this as a header. So I can customize this, and also if I need any sort of main image, I have selected this, and then I need to drag here. So now this is the header. Along with this, if I need any sort of table, I can just paste a table here. So that table will be automatically getting scrolled. Just now, I mean, like right now I don't want any sort of table, but I can also add a scrolling text here. So for example, I have a scroll here. Now let me type this is the demo. This is a demo showed by Karthik. Let me give a color of blue here, and then check out here. Now let me upload this to the ESP. You can see here it's uploading. This is entirely microcontroller based I mean, like a program or hardware. It is not at all a microprocessor. It's pure 32-bit cadence extensor based microcontroller architecture. It's not a processor. Each and every detail on the screen is purely controlled by bit manipulation in a microcontroller. So now it is uploaded. It will take a reboot. It has a developer flash. Now after a little time, the demo has started. So this is a demo shown by Karthik. Yeah, thank you. Now let us talk about the challenges in this project. So the first thing is we need to drive the resolution. Basically, if the resolution increases, the more of the instruction cycles, which it bursts the instruction cycles, and then the more of computing, which is very critical in memory. So which indirectly needs so much of memory, but we have very limited I mean, memory on the ESP32 S3. So that is why what we have done in the sense basically I majorly concentrated on 640 into I mean, like 480 resolution, which is a standard, which is a basic standard in any sort of VGA devices. So that is how I have made it to 640 into 480. I can also interface an external RAM module to the ESP32 S3 with octal SPI or quad SPI, and then I can increase the resolution up to 1080 into 720p or 1080 into 1020 pixels. So that's the standard ratio what I have tried to I mean, like maintain in this project. So next, talking about memory constraints, there is a PS RAM, that is pseudo RAM present on the ESP32 S3 of around 8 I mean, like MB. I'm trying to utilize that memory also to I mean, like load the data and then to run the server and then to pick up the data. Instead I mean, like the storage or the payload what I receive from the external client, that means HTML plus CSS interactive dashboard, I'll be storing that data into a flash memory, and then I'll be retrieving that memory whenever required based on the requirement into RAM, and then I'll be utilizing that to show on the screen. So this is the actual controlling method what I have used.